Okay, so welcome back to another video. So in today's video, we actually no equations this time. We actually got this little geometry problem over here. So inside we have inscribed in this little circle, there's some triangles. Right over here there's like a square, and then there's probably like a trapezoidal piece in here. But with each side of the square, this is 3 meters, 3 meters. But then particularly this piece from meeting at this center from here to here is 1 meter. And now the question we are being asked is to find the area of the shaded region. So we have to find the area of this added with the area of this. So I know at first glance it's probably going to look a little too complex. Especially you might thinking that there's probably no possible way on how to probably calculate this area. But if we actually do a couple of interesting methods here, using like some with our geometry techniques, of course, then things will come down nice. So I'm actually just going to use this orange marker, since using black marker in this case, if I were to usually write on stuff, it probably might be a little out of place, especially since we have this calculating the black area. Okay, let's actually let me label some things first. So how about I call this the center over here, that's actually the radius, or I mean the center. I'll just call this O, and that's the center. All right. How about I call this point over here B? I'll call this point over here A. And what I can actually do is I can actually draw a dotted line extending from the center all the way to the side length over here. So let me just draw just a dotted line, and then you'll see that we can see that this shares the same length over here. So the dotted line's length from here is actually 3 meters as well. And what I can do over here is I can also extend this line from A all the way to the line here. So let me actually extend this line out a bit first. Okay, just leave it as that. Now I'll just extend this down. So I know this is just a little crooked, but don't worry about that. So over here, that means this forms a right angle over here, and I'll call this point over here where the two lines intersect, I'll just call this N. Let me actually call this little area over here S1. And I'll call this little area over here S2. So really, finding the area really is we have to find what S1 plus S2 is equal to. Okay, and let's see. So we noticed that because O is the center of this entire circle, so you can clearly see that OA and OB, they're actually the radius. So this means that these two lines are actually congruent to each other. The two orange dashed lines to indicate this. And we can see that because this is a square, so this shares 3 meters here, 3 meters here. You have 1 meter over here, so that means this side over here from here connected to the the perpendicular. This is the word I meant to say. This is actually supposed to be 2 meters over here. Okay, now using the conclusion with this, let me actually label this as O. Let me actually label this point over here as OM. So, or M is here. So the length OM, we can see that because using the congruency of the lines AB and OA, and if we actually construct the triangle BNA, what I mean was, like, if we focus on the triangle, we can see that using the congruency, we know that the triangle BMO is actually just half the area of its triangle. So in other words, we come to the conclusion with this length that OM is actually parallel to AN, and I also state that OB is equal to OA. So because they're just the radius. Calculating this from here is pretty simple. Let's see, calculating this triangle over here, so it means S1 is just equal to let's see, it's just base times height divided by 2, so it's 2 times 3 divided by 2, and it's just equal to 3. Okay, so we found our first piece of the area. Now we have to find the second piece. So S2. So what I'm gonna do is actually we're actually going to take the larger triangle. So triangles BA and this piece over here, Even though we said that, because this is an obtuse triangle, so really it's just using the same formula for calculating the area of a triangle itself. So basically, this is the area from, or the length is measured from 3 meters. Its height is measured from 6 meters, actually. I should probably state that. So the height from A to N is 6 meters. And we say that simply because this is actually using the congruency that these two radiuses are equal to each other. This is just half its, this triangle over here specifically is half the area of the bigger triangle, BNA. So we specified that the length is 6. So using the area to calculate the triangle from the obtuse triangle, let me actually just label this as P, just for the sake of it. So triangle BPA is the triangle we're trying to calculate, and then we're actually going to subtract that piece from the trapezoidal of the unshaded region over here. So BP, the length of BP is 3, then we take its height, so length NA 6, so this is 3 times 6 divided by 2. Okay, and then I'll subtract that with the trapezoidal area over here. So we know the trapezoid area is equal to your base 1 plus your base 2 multiplied by your height and then divided by 2. So then really this is, let's see, so it's 3 plus 1, okay? So it's just 3 plus 1 multiplied by our height, 3, and then divided by 2. And then you'll see that we get that, I'll write this down here. So we get that this is 18 divided by 2 minus, let's see, 3 plus 1 is 4 times 3, 12 divided by 2 is 6. So 6, I'll just write this further. This is 9 minus 6 is equal to 3. That's our S2, and we're just about done. Put the, calculate the sums together. We get that this is 3 plus 3 is equal to 6. Like so. Alright, that's pretty cool if you ask me.